Hi, everyone. Last class today. It is now 2 p.m., so we'll go ahead and get started with lecture. Yes, I can turn my video on so you can see me. Hi. So before we jump into the lecture, I just want to cover a few things for you guys. And then if you have any questions, I'm going to give you some time to ask them now. If you have questions about the exam or quiz or anything like that. And then Carrie and I, of course, will have office hours later today if you have further questions. So, as many of you know, Exam 5 opens today after class. It's due in a week on May 12th at 3 p.m. And I've been getting some questions about whether or not you can look at the exam first and decide if you'd like to take it. It's on Blackboard starting at 3 p.m. or no, yeah, 3:30 p.m. So you are welcome to look at it, decide if you want to take it. Whatever score you get, if you don't take it, you get a 0, but we will drop that score assuming that's your lowest. So you can kind of do what you'd like with exam 5. We wanted to give you guys that option and decide from there. And then I've been getting other questions about whether or not there's extra credit on it. There is an extra credit question, but again, after class, you guys are totally welcome to look at it. Um, just a reminder, today is our last class. We do not have class on Thursday. Instead, what Carrie and I have decided to do is to have somewhat extended office hours on Thursday. So we'll be online from 3 p.m. to 5 p.m. on our usual Zoom link. Otherwise, if that doesn't work for you, you can make an appointment with us. And I think the best time would just be during what would have been normal class time on Thursday. So if you can't make 3 to 5, then maybe, we can do something around 2 or something. But just shoot us an email. Otherwise, we won't be online until 3 o'clock on Thursday. And extra credit that's due May 12th at 3 p.m. On your original schedule, it said it was due earlier, but we just decided with all the craziness to let you guys turn that in on the last day of class on the final. But we will not accept anything after that 3 p.m. deadline. So make sure if you want those extra percentage points, you get it to us sooner rather than later. And we've been getting questions about whether or not we've received your extra credit. So what we're going to do is we'll post online in the grade book whether you have a 0, 1, or a 2 on our list for extra credit. If you disagree with that list, you think you should have a 2 and we gave you a 1 or a 0, email us with the proof of your extra credit. So if you did an online study like the one from our lab, then just email us that link again. We might have missed it in all of the ones that we got. And then finally, the last thing, we just want to thank you all for your feedback on Quiz 5. You guys had a lot of good stuff to say about the topics that you really liked and how you thought it would help you in your career. And we really take this feedback seriously. And Carrie and I are early in our teaching careers, so that was super helpful for those of you that did it. We really appreciate it. So before I jump into talking about writing, are there any other questions you guys might have going forward?
I have a question. So if we decide not to take the final, as of now, our grades shouldn't change, right? Like if there's going to be nothing going into our grades if we decide not to take the final, or?
So we haven't graded the last quiz, but pretty much as long as you did it, you get your 16 points. So that's the only thing that we haven't graded up to this point. So yes, if you're totally happy with where your grade is now, it's an A or a B, whatever you're happy with, don't even have to open the final if you don't want to.
Thank you.
Mm-hmm. Plus, oh yeah, Carrie mentioned there's also the extra credit. So in addition, we'll post that online as well. All right. Anything else for you guys? Okay. If something, you guys think of something, again, you can, it's probably just easier to ask us at the end of this lecture if you're on. Otherwise, of course, you can email us or talk to us in office hours. Okay, so moving into our last topic of the semester. So again, we'll be talking about writing today, and this one, Carrie and I wanted to add into the materials you'd learn because writing is a very overlooked topic. There's not a lot of research on it, and it's kind of an underserved field. But there's a lot going on, you know, just with our brains in writing, with disorders in writing. So we thought it would be nice to just give you guys a little taste of what writing is like, how it's kind of looked at linguistically, and then moving forward, you know, you'll have that in the back of your mind when you start learning about more and more about these other topics. So for today, we're just going to look at the evolution of some writing systems, going from pictograms to letters. We'll talk about some of the main properties of writing systems. So we'll define grapheme, look at the 5 writing system classes. Then we'll talk about these 3 broader types of writing systems. And then we'll go into some writing in the brain. I know a lot of you guys mentioned in quiz 5 that you really liked the brain stuff. So I wanted to add in a little bit about what we know for writing in the brain and the kind of cognitive model we have with that. And then some of the disorders that can result from damage or neurological developmental differences in the brain. So starting with the evolution of writing systems, the earliest writing systems utilize what was known as pictograms. So this is just like the image you see here in this on the slide. So for this image, it probably represents something like fire. And pictograms are usually iconic, so that means the form of the image directly relates to the meaning. So if you guys remember all the way back to when we were talking about animal communication, we would say that this is a non-arbitrary sign because it's directly related to its meaning. However, as language systems and writing systems developed, we started to see more semantic extensions of these pictograms to where more abstract concepts were represented and the scope of the meaning for these pictograms were expanded. So an example just pulling from English would be something like a symbol like this extending to the meaning of hot or the meaning of bake or something like that. And when we start talking about these symbols extending beyond the pictogram, then we no longer really refer to them as pictograms. We would start to refer to these as morphograms because they have further meaning behind them. And we'll look at what a morphographic system is like in a little bit to kind of expand on this concept. So following a semantic extension, there was then these phonological extensions. And that what that meant was that eventually these sounds begin to be associated with specific symbols, or excuse me, the concepts were associated with specific symbols. So for something like hot or a picture like this, we started to get associations with different phonological letters or symbols or phonemes. So for example, we would have hot, the hot, and fire. And then finally, these sounds from these phonological representations were then extended to other objects or feelings or actions. So that would be like taking each of these phonemes in hot and extending them to other words. So the h would be go to hand, the ah would be to on, and the t would go to taste. So that's really the like broad idea of how these systems in the earliest writing systems went from like cave drawings and all these like really cool carved things into the representations that we have now. And I illustrated this with English, but let's look at what this actually looked with more like ancient texts. So with languages like Sumerian or Egyptian or ancient Chinese, you would see where these pictograms here would really represent or kind of look like what the concept that they were representing. So an ox had this like these horns and a face, a star, looked like something you would see up in the sky. All the water symbols kind of have this like squiggly movement to it. And then eventually that would extend semantically. So then pictures that were originally just representing a knife would then extend to these concepts of cutting and slaying, or fire would extend to cooking and burning. And then finally, these would extend phonologically. So these symbols, this bird might now represent flying, and the phonological symbols that are connected to that would be something like moot or something like that. And then we also see this kind of more specifically with how we got our writing system. So in these early systems, when we looked at pictograms of things like an ox, you saw it had like these horns and this face, and eventually that was adopted by into like the Phoenician symbol inventory. And you can see there how it still kind of retained that those ox-like features. And this Phoenician symbol here was akin to something like a glottal stop. So when the Greeks eventually adopted this symbol into their language, they didn't have that sound at that time, so it got adopted as more of an A sound, and they called this symbol alpha. So all of the names for Phoenician characters were adopted into like Greek and Latin alphabets, and then they were adapted based on the phonological inventory that they had in those languages, which is how we ended up getting our current Greek and Latin system. So that's just kind of the general pattern that linguists and anthropologists have identified for how we got from this cave drawing to this letter on a keyboard or on our cell phones. So moving into the properties of written language, there's some general ideas that go along just like with all writing systems. So we'll go ahead and look at these in more detail. So writing exists separately from language. There are many languages around the world that do not actually have a written form, and a lot of cultures don't really value written communication. So a lot of Native American tribes will pass on their history and stories orally rather than writing them down. And unlike language, writing has to actually be explicitly taught. So if you, what like we learned from the child language acquisition section, if you have a child that's in perfectly normal language conditions, then they'll just seem to acquire language. There's some kind of innate aspect and some kind of learned aspect with language. However, with writing, you have to explicitly teach it or you will not acquire it. And it relies heavily on the phonology and the semantics of the language. So that's really the sounds and the meaning are really what drive a writing system. And within writing systems, a grapheme is considered the smallest unit of writing. So just like a phoneme is the smallest unit of sound for a language, we would say grapheme is the smallest unit of sound for writing. And with graphemes, individual graphemes can represent one sound, or multiple graphemes can represent a sound. So when we look at one-letter graphemes, those are things like and mat, but two-letter graphemes are things like sh representing sh, or IGHT representing I, and EIGH representing A. So this is actually, for English, what makes our system sometimes so complicated to learn is there's not a direct mapping from our graphemes to our phonological inventory. And because that mapping is not one-to-one, it can be kind of hard to learn to spell and to kind of learn these sound patterns of English, because this doesn't really, if I were to pronounce those individually, I wouldn't really come up with A for that. And the connection between these graphemes and the words that they represent is arbitrary. So again, remembering all the way back to animal communication, there's nothing inherently about s, h, I, and p that represent a ship. But when we put them together, because of these social conventions that we have in our society, we recognize these sounds together as representing something like this. So what we say with graphemes is that in these phonological systems is that they're very arbitrary. And as you guys saw with like pictograms and morphograms, they're a little less arbitrary. So moving to the 5 writing system classes, there's kind of like 5 broader ones that we recognize. And the first and most general category, and usually the category you think of when you think of writing, are orthographies. And an orthography just refers to the symbols and the rules of a language's writing system. So for example, in English, we know all of the letters of the alphabet, and we know for rules that every syllable has to have at least one vowel in it. And we know that the vowels are A, E, I, O, U, sometimes Y. So that's the orthography of English. When we talk about pedographies, we talk about writing systems that are designed for learners. So one example we'll expand on a little more is this idea of an abjad. An abjad actually has a pedography. So an abjad is a language without vowels, and they're just kind of like understood by the speakers that they're understood in pronunciation. But when learners are learning this language, these languages that are abjads, they'll often include the vowels in the writing to help the learner learn, and that's considered a pedography. We can also talk about technographies. A technography is a scientific tool or some kind of like system of notation for a specialized field. So the one that you guys are probably the most familiar with is the IPA in linguistics, or in the study of different sounds of languages. So that's a tool for linguists and speech pathologists to describe the sounds in a language. Another example are things like chemistry. They use that periodic table. So that's a scientific tool or in a system of notation for them for the things that they needed to represent in their field. Shorthands are another class, and this is just abbreviation or symbols used when you're writing rapidly. So I'm sure all you guys use shorthand when you're taking notes or typing quickly on a computer. Court reporters use them a lot too. So they use what's known as a steno machine to transcribe court cases. And if you actually look up some of these transcriptions, they like legitimately look something like this. And it's like, seems like it's completely meaningless, but for a stenographer, they actually carry meaning. And I definitely went down a rabbit hole looking at how they do this. Really cool stuff, but like combinations of letters represent certain things. So they want to do like a question mark, they like pick 4 letters and that's a question mark. So it just kind of looks like gibberish. Then finally, there are cryptographies. So these are codes designed to conceal information. So you guys might have played these kind of games on your phone or trivia nights or something where you're trying to figure out what this like code here actually means. And an example of this for a machine that was able to crack these kind of codes was the Enigma machine created by Alan Turing. That actually was just like the codes were just a level of encryption and they had to be cracked. And so that was a cryptography that the Germans were using. And this is really the basis for encryption software. So moving forward, some properties of all writing systems. Different systems impose different orientations on the writing script. But once that orientation has been selected, then that's all that they use. So this is just an example with like English and Arabic, where English will always write their writing systems from right to left. If I did it from left to right, that would be wrong. Arabic uses left to right. There are some systems that write from like top to bottom as well. And once that system is selected, that's the only way they will do it. Most symbols are composed of around like 3 writing strokes that can be traced without lifting or stopping the pen. But there's no writing system, I think, that people have found that has more than 4 writing strokes, which really tells you something about writing, how it has to be easy enough for it to be adopted. If it's too complicated, then it won't be used. So an example is with English, we can just say like the number of strokes in writing for different letters. So C, I, J, O, S, and U would just be 1. Letters like E, M, and W would be 4. I feel like I can make some of these without lifting my pen, but they're considered 4 because they're 4 different movements. And finally, the most common shapes across different writing systems are those that correspond to shapes most frequently seen in nature, which I think is really cool. So these are shapes like L and T. And the reason is these shapes are especially salient to the human brain. So if you look across all these like different scripts and different writing systems, you'll see some of them are kind of exceptions, but you'll see this repeating pattern that's kind of like line based with a thing extending off of it. And that just seems to be the most perceptually salient to our brain. So that's why most systems utilize those. Okay. So I just wanted to very briefly talk about sign language. I know a lot of you guys mentioned in your quiz that you would have preferred a little more information on sign language. So I just wanted to throw in my minimal knowledge on that for you guys. But most signers will rely on the writing system of their dominant language in their country. So most signers of ASL will just use English in their writing. But there are some writing systems that have been proposed for sign language. So this is the Sutton sign writing notation. And with this, if you read through it, this is actually the writing notation for the sign who. And it actually has a lot of detailed information on it. So what you see here is that the eyes and the mouth represent this, like the brows squeezed together, the lips pursed. The arrow indicates the tilt of the head, so the head being slightly forward. And then the bottom symbol represents the hand shape and the palm orientation, and these 2 dots indicate a double movement of the extended index finger. So these symbols kind of get all of those salient features that a signer uses to convey meaning. But for the most part, these symbols haven't been widely adopted. And instead, when you look in a sign language dictionary, usually what you see are the written forms of the sign are these like pictorially represented signs. So if you ever Google how do you sign this, usually you'll just see some kind of pictorial representation of it. Okay. So now moving to the types of writing systems. Do you guys have any questions so far? Or should I keep going forward? No, I'm kind of blasting through this one.
I have I guess it's a comment for the ASL writing system. I know that when I was taking up ASL in community college, we were taught glossing. And so glossing is kind of like writing in the syntax that ASL is signed.
Yeah.
So it goes like TT dad, like time, topic, detail, action, and then doer of the action. Mm-hmm. And so we were like taught that and taught to gloss that way. And then there were different kind of symbols for the different classifiers that were used in the language, so that if you read it, you could sign it and it would be an ASL structure, but just written down in English.
Yeah, that's really cool. Thank you for that information. If I ever teach this section again, I'll definitely add in glossing because it has some really interesting characteristics to it. And I always think with glossing, like you said, it maintains that syntactic pattern, right?
Yeah.
Remember? Yeah. Mm-hmm. And we didn't really go over this in the class, but ASL sign does not have the same syntactic pattern as English. And I think that's kind of the common misconception. So great point. Thank you for bringing that up. Okay, so moving into the different types of writing systems. So for this class, will be talking about three main writing systems. The first is a morphographic, or sometimes called a logographic, a phonographic, which consists of syllabic and phonemic writing systems, and then the third is some kind of combination of both. And on this image on the slide, what you guys see is a breakdown across the world with the type of system that is used. So you see that alphabetic systems, which fall under phonemic, are pretty common, especially where we are. So North and South America, a large part of Africa, Europe, Australia, all that. So it's a pretty common system. And then you have the logographic and syllabic, and then abjads and abogidas, which we will talk about under phonographic. So for a morphographic writing system, these are meaning-based writing systems where each grapheme corresponds to the meaning of a morpheme or the meaning of a word. So highly morphographic systems are things like pictograms. So like back in the ancient writing systems, those pictograms are, as they kind of were semantically extended, begin to represent morphograms or morphographic systems. And this is also seen with traditional Chinese. So there's different ways of writing for different Chinese languages, but with traditional Chinese, these are morphographic systems where these graphemes here represent these entire concepts of love and horse and noodle. This might be kind of hard to picture with a language you're not familiar with, so we actually do have these in English as well. So these are things like our numbers, so 2, 9, and plus. There's nothing about the pronunciation in these symbols at all, but I know how to pronounce them because they represent this concept of 2. So when we use it like this, these are actually considered morphographic. We know the symbol is nothing about and, but we know to say it as and. And what's important to note here is that even though English does have these morphographic symbols, it does not mean that it's also a morphographic system. So generally when you're classifying these, you just look at what the, in general, what the writing system is, even if it borrows elements from other systems. Moving to a phonographic system, these are sound-based systems. So the first one that we'll talk about are syllabic systems. So a syllabic system is when each character represents a sequence of sounds, which usually correspond to a syllable. And the characters that are used in syllabic languages are referred to syllabaries or syllabaries. I never know how to say it. But that's like the same sort of thing that we have in English as an alphabet, but for a syllabic language. So what you see here is an example from Japanese. I'm just gonna put this all on the slide for you guys. So Japanese actually has an interesting system where they use both phonographic and morphographic aspects, depending on the writing system being used. So the phonographic elements are hiragana and katakana, where hiragana is usually used for function morphemes, and katakana is usually used for loan words or onomatopoetic words that sound like what they mean, so like boom or bang. And kanji is a morphographic system that's usually used for content morphemes. So what you can see in this image here is that you see the hiragana and katakana symbols that correspond to syllables. So ka, sa, ta, na, ha, ki, shi, chi, like that. So these symbols actually correspond to entire syllables in the language. So now talking about phonemic languages, or phonemic writing systems, I should say. Phonemic writing systems are probably what you guys are most familiar with, as many of you are English speakers. And these represent individual sounds or segments. So there's 3 different kinds we'll look at. The first is an abjad. And these writing systems only represent consonants. So an example of this with a English alphabet gloss would be something, I think this came from Hebrew, which is read from right to left, where you don't see any vowels here. It's just g, and o, and that represents gamal. So the speaker knows to add this a sound, and that means camel in the language. So if you think about this for English, some might think that's kind of hard to do and it might be confusing. But really, if you look at this example, what do you guys think that this is saying here? So this is an example from English with the vowels removed. Can you guys all read what this is saying? You understand it? Just want to put in the chat like yes or no, I can read it, or take a guess at what it says. Yeah. Emily says, what are your plans for summer? Exactly. So we kind of have this knowledge about vowels that we don't really need to include them in a lot of cases. So these abjads, they may sound confusing, but actually you can get a lot of the phonemic information without including the vowels. So you can see that it's actually, still a productive system in English if we decided to do this for some reason. Conversely, if we just had the alphabet, or just the vowels here, can you guys guess what this is saying? Audrey's like, nah. Yeah, so this is actually saying the same thing. What are your plans for summer, but just with the vowels? So you see that that would be very complicated. So there's actually no writing systems that only represent vowels, but we have plenty that also that only represent consonants in a language. The next one is abogidas. These are writing systems where the consonants are represented with graphemes and the vowels are represented with additional diacritics or just like extra marks on them. So an example here comes from, I'll probably say this wrong, but Devanagari. And what you see with this example is that you have your base form, which is ka, and these sounds, they exist within what am I trying to say, a vowel on them already. And then when you want to add a different vowel, you have to include some kind of diacritic marker in some way, some other kind of way. So the base symbol for something like k is going to be this, and then you include additional symbols to reflect different vowels. And that symbol for let's see, when we look at key, it looks like it adds this line here and this extra loop. So this E symbol is going to be the same no matter which consonant it's with. So it'll always be this symbol with a consonant. That's abogidas. And then finally, the one that you guys probably are like, why the heck are you telling me about alphabets? These are the third phonemic system. So writing systems that represent all the consonants and all the vowels of the language. So you know the Roman Latin one that we use, but there's also ones like the Cyrillic alphabet used for Russian and plenty of other languages. And then I think there are a few other across the world. So these are the three phonemic systems. And then the third system is a combination of morphographic and phonological writing systems. So as writing systems evolved, as you guys saw, morphographs were used to describe concepts based on their phonemic value, like you guys saw on the first couple of slides. So this is actually referred to as the rebus principle, where you use a symbol just for its phonetic value. And we can do this with texting, with fun little word games where we take one symbol, and because this symbol is a B, we can now use this B sound to make other words. So B, leaf, eyesore. I kind of glossed over that one. I don't know how that says sore. I think it says saw, and it's supposed to sound like eyesore. These ones are a little clearer. Sealant, tree, sun. So that would be the rebus principle. And most morphographic systems are no longer purely morphographic, but they also make use of this rebus principle to represent further concepts. So an example of this would be something like from, I think this is from Chinese. I should have written that down. Correct me if I'm wrong, but I think it's from Chinese. So what this would do is you have this base phonetic symbol for wheat that sounds like lie, and it would be represented with the meaning component. So this would be the morphographic symbol for wood, the sound symbol for lie, and that would be translated to large-leaved dogwood. And you can do that with different symbols. So mountain plus lie, gold plus lie, and you would get the word meaning from that. Oh, Kaylin says it is Chinese. Thank you. I always should write down the languages that I have examples from. So we can do this with English as well, just to make this a little clearer for you guys again. We can take the meaning symbol for something. So if I saw this picture, I would say ear. We can combine it with a sound symbol and make a word. So that would be something like here or beer. We can do this with other symbols at the front. So we can take B at the front and do B plus B to make beep or bead. So this is really a combination of both a morphographic and a phonological writing system. And most systems, you know, I said you can have morphographic, or you can have phonological, or you can have some combination. Most systems don't exist on these extremes of like purely morphographic or purely phonological. They kind of borrow certain aspects from other languages, and you can see like this, where we would classify English as a phonological system, but I can take aspects of a morphographic system to create words if I want. So when we, again, I think I said this already, when we classify them, we look at the predominant way in which the language is represented through writing in order to categorize it as one system or another. And then those that really use like a blend of both would be this combination type of system. Okay, so if there's no questions on that section, I can go forward with talking about writing in the brain, including a little more brain stuff for you guys. Okay. So for writing in the brain, there's a general cognitive model that's just widely accepted and has a lot of agreement, which I think in the field is very unusual. Usually there's like camps for different models that people accept, and you guys have kind of been getting a taste of that when we're like, there's this, but there's also this. But this one is pretty widely accepted in the literature. And so with this model, what happens is if you are going from speech to writing, what would happen is the speech input is processed along a pathway that leads from auditory feature analysis through this phoneme system to the phonological lexicon, where the sound structures of perceived words are recognized. So that's where you really get like that structural input by breaking down the phoneme and recognizing what it is, those phonemes. And then from there, the spelling patterns of the very same words are accessed in this orthographic lexicon. So this is where we translate that into spelling. And at this stage, the graphemes are just like unspecified for size and case and style and how they look. And here, the abstract patterns, these like abstract spelling patterns of words, can be retrieved from the orthographic lexicon in two different kind of ways, depending on how you're processing the words. So one goes straight from the, I think it's straight from the phonological lexicon to the orthographic lexicon, and the other passes through this semantic system. So when you're passing through this semantic system, that's usually because you're not beginning with auditory speech input, but rather with some kind of conceptual like thought or feeling or idea. Like, for example, when you want to write a letter to a friend or something like that. So after passing through this, it then passes through this graphemic buffer. And this is basically a limited capacity working memory system that temporarily maintains in this activated state the identity and the position of the appropriate graphemes while the word is being written. And so that's like, if it has, you know, just regular graphemes, that would just be like translating this sound for desk to desk or something like that. And then it moves down to this allographic conversion where you really start to prepare to actually write out the word. So it involves like translating the letters, these abstract letters in this graphemic buffer to like upper or lowercase or like separated out or cursive letters. So it kind of takes those abstract representations and brings them to something more concrete. And then finally, the graphomotor planning system is what you like actually prepare to do that motor writing. So this is the wide system. And you see, you can also, if you're just like copying things, you can kind of skip these steps in between where you have to like maintain and translate and just go directly from the phoneme system to this buffering system. Okay. Oh, and I left the some citations in there if you guys are like just so curious about this. A lot of these will explain that for you. So moving a little to writing and the brain, there was this widespread study. It was actually what's known as a meta-analysis, where it looks across all of the literature that has published on this, and it tries to figure out, what do we know about writing in the brain? So this one from Purcell et al. Ended up identifying different areas in the brain that seem to be critical to writing. So the areas that are in red are associated with the orthographic lexicon and the graphemic buffer and the phoneme grapheme conversion pathway. So those are the different elements on the model on the previous slide. Then the blue areas are associated with allographic conversion and graphomotor planning. So what they found was that the spelling patterns of words seem to be stored in what's known as this visual word form area, which contains a single orthographic lexicon that contributes to both reading and writing. So you can see how these things are kind of connected. And then this phoneme grapheme conversion seems to rely on several different like frontal, temporal, and some parietal areas. That graphemic buffer that's involved in working memory is largely in the inferior frontal cortex, including Broca's area, so this region here. And then allographic conversion and graphomotor planning is this like, planning is in the frontal lobe, and then there's a lot of like motor stuff up in there. Those are kind of the main areas. And interestingly, we talked about these different types of writing systems. So there was a study by Cho et al. That was looking at the processing differences between morphographic and phonographic systems. So they looked in, I think this one was Korean. Again, need to write down my languages. Oh yeah, I said Korean there. And so what they did is they compared regions of brain activation while participants wrote using two different scripts. So using Hanja, which is morphographic, and Hangul, which is phonographic. And what they found was that Hanja and Hangul recruit different neural regions that are believed to be related to processing semantic meaning versus processing phonemic meaning or phonological meaning. And there's relatively, like when you compare the two, the areas of the brain that are activated are pretty widespread. So on the previous slide, you didn't see that much color on it. On this slide, you see when you look at those, there's a lot of activation for those. But the problem is that there's a real lack of literature in this field. So it really is open for research and for study for speech clinicians to kind of understand how writing in the brain works. But it seems that when you're looking at a specific system, it kind of has these same, like the visual word form area is activated across all languages, but then depending on how your writing relates back to your language, you can see different areas of activation. Okay, so now we're just going to talk a little bit about some writing impairments. So when we look at writing impairments, we can talk about dysgraphia, which is a developmental disorder. And then on the next couple of slides after that, we'll talk about agraphia, which is an acquired writing disorder. So dysgraphia has to do with difficulty with written expression, and it's related to something neurological, but the underlying causes are not clear. So with SLI, as I said to you guys, we know that it's neurological, but it's just not exactly clear what is happening. It's even less clear with dysgraphia. And it does seem like dysgraphia has a strong genetic component, and it often gets compared a lot to dyslexia, even though these two are separate impairments. They are different. They can be distinguished between dysgraphia and dyslexia, but sometimes there's comorbidity between the two, meaning a child can have both. And so the first type of dysgraphia has the word dyslexic in it, so it can be a little bit confusing, but just know that these are different impairments. So there's three types that are typically talked about: dyslexic dysgraphia, dysgraphia due to motor clumsiness, and dysgraphia due to a defect in understanding space. So when we look at dyslexic dysgraphia, it seems that spontaneously written text is really hard to read, and oral spelling is usually pretty off. And so a lot of times you'll see like semantic substitutions for the spelling and just really incorrect spelling forms. However, they seem to still be able to copy over written text just fine. So it's like, as long as they're copying, they can kind of skip some of the pathways on that cognitive model. But if they're having to do it more spontaneously, you see greater issues. And again, they're able to draw as well. So it really seems to have something to do with that writing process. And then with these dysgraphias, we usually look at finger tapping as well to check motor abilities. So in this dyslexic dysgraphia, motor abilities seem to be intact because you give them a finger tapping test and they can do it just fine. So an example would look something like this. This is a child who has comorbid dyslexia, but you just see that by grade 4, this is still like pretty sloppy writing, and it's just kind of inconsistent in size. A lot of times you'll see capital letters in strange places. And then here, I don't know if this is supposed to be sync or what that X is doing there. So you'll just see this is kind of a more mild case, but you see that the text is just kind of hard to read. This next one is dysgraphia. So with dysgraphia, written text is really hard to read, as you guys can see. However, spelling still seems to be intact. And if you ask them to copy written text, they no longer can do that in a legible way. They don't seem to be able to maintain drawing abilities, and their finger tapping is a lot slower. So typically what we see with dysgraphia due to motor clumsiness is that the actual like motor aspect of writing is impaired, but spelling and those kind of that knowledge is still intact. And then finally, dysgraphia due to spatial impairments is where, again, the text is kind of illegible. I know that's a small picture, but oral spelling is preserved. Copying text is oh my gosh, I can't say that word sometimes, not legible. And drawing is abnormal, but finger tapping is intact. So as you can see with this one, you can tell that the writing becomes really slanted. Sometimes they like write in different fonts throughout. So it's just like some of the words are really spaced out, others are really close together. So it really has to do with this like spatial impairment. So those are the three types of dysgraphia. And again, it's really not understood that well. There's some kind of genetic factor. But when we look at this neurologically, it seems like the greatest differences across children with dysgraphia and typically developing children are differences in the parietal and frontal lobes. And then there's this meta-analysis, so taking all of the studies in the field done by McCloskey and Rapp, and they reported across these different types disruptions in different areas of this cognitive model. So there's some long-term storage for orthography can be impaired, so knowing the actual graphemes and the rules of the language for spelling can be impaired. That sound to spelling conversion here might be impaired, or the orthographic working memory, this graphemic buffer, knowing what you heard or what you want to write and translating that onto a page, that might be impaired. There's just a few theories. Again, I feel like I say this a lot, not totally clear what's happening. Finally, going into agraphia. So this is an acquired writing impairment following any kind of neural trauma to some of the writing centers of the brain. So this could be from a stroke, it could be from a TBI, it could be from things like that. And there's 3 different types. There's phonological dysgraphia, surface dysgraphia, and deep dysgraphia. So we'll look at each of these ones. So for phonological agraphia, this is a disorder of writing to dictation in which patients perform significantly worse on pseudo words than real words. So what you'll see when we talk about agraphia is it's usually studied in terms of someone saying what the person needs to do or what the person needs to write, and then having to write that down. So that's the writing to dictation tasks. And then it's often compared with real words that have normal phonological order to pseudo words that are still acceptable in the language, but we don't see every day, so we can't rely on memory aspects to be able to be oh, I know how to spell pen, I spell that all the time. So that's why they usually test with pseudo words. So what you see for phonological agraphia is that with this person, they would get these pseudo words and then they would be asked to write them down. So with this particular participant from Bub and Kurtz's study, they tend to get pretty close in form, but they're usually just a little bit off with which phonemes they heard or what order they go into. But in terms of oral speech, they're just fine. If you said it to them, they said halfy or whatever, however you say that, they would have no problem doing that. But when they write it down, they seem to have impairments. And with phonological agraphia, patients tend to have more general speech processing deficits. So these impairments may just be a byproduct of some kind of reduced phonological capacity or some kind of phonological impairment. So for someone maybe with conduction aphasia, you might see some phonological agraphia with them. Surface agraphia is a disorder of writing to dictation in which patients perform significantly worse when you give them irregular words, especially when those are low frequency words. So irregular words are words that aren't clearly spelled in our language. So a word like cat, you can kind of hear all those sounds and it's clear which letters they would map onto. Whereas irregular words are words where it's a little less clear. So you get these with a lot of borrowed words or words that have changed a lot over time. So examples would be things like cushion or nuisance or urge. It's not really clear that that's how you would spell those words. And with surface agraphia, you'd see that especially when they're irregular like this, they really struggle with how to write them down and how to spell them. And this is because it seems that the phoneme grapheme conversion, that functions normally, but there's some kind of disruption that affects that orthographic lexicon conversion. And finally, deep agraphia is a disorder where patients are more impaired on pseudo words as well as real words, with errors on the latter often being semantic in nature, and they tend to perform more worse on more abstract items. Let's look at this. So this, and here, this is with regular nouns. So this is them getting a word presented orally and then having to write it down. And you see that they do okay on this. Like there's a few errors here and there. You see this semantic error here, chair to table. But for the most part, they do pretty well on this. When we look at irregular nouns, they're kind of still doing okay. You start to see more errors, but things like castle, circle, they're doing just fine on. But then these ones here are pseudo words. You start to really see that kind of breakdown for them. So huffed is fact, soom is moody, shad is foul. I mean, there's no real connection. So you really start to see that breakdown, and you see across, you'll see a lot of like semantic difficulties there with writing down the correct word. And the difficulty with pseudo words most likely reflects an impairment at some point along the phoneme-grapheme conversion pathway. But these semantic errors with the real words are not entirely understood, and they actually need a lot more research because it's kind of unclear why they're making these semantic errors. This is just a chart to summarize if you guys are interested to see across these different types and how they perform on different types of words. But other than that, that is all I have for you guys for the last class. For those of you that are still left on here, I really appreciate you guys joining in. It made these lectures a little better to have to give in this format. So thank you so much for sticking with it. I know it wasn't easy throughout the semester. That's all I have for you. If you guys have questions, feel free to stay on. Carrie and I can answer them. Otherwise, talk to us in office hours. And I hope you guys have a great summer. Thank you, guys. Thank you. Thanks, guys. I wish I got to teach you in person. You all seem so great.
Thank you. Bye.
Bye. Thank you. Okay, it sounds like there are no questions. So Carrie and I will be over in office hours around 3:30. Feel free to join us there if you do have questions. Thanks, guys. Bye, Carrie.
Bye.